So if you just walked in, a couple of you just walked in, again, everybody else has heard me announce this quite a few times. We're going to be using Google Gemini. So go ahead and log in. If you got a Google account, it should be straightforward to get into. I've also got a Google Doc that you can hit with this bit.ly, this link right here. It's got the prompts that you can follow along. It might be helpful toward the end when we get into some longer prompts going on. It might be easier to cut and paste from there and plug in. So we have that as a resource. And lastly, if you want to use their Wi-Fi, we're under CyberCamp with the To Be Smarty AI password spelled interestingly the way it is. Okay, so here's the overview of what we're going to get into. So artificial intelligence, how we got to now. We're going to talk about large language models, kind of under the hood just a little bit. We're not going to get super technical, but we are going to get technical enough that it gives you some context as to what's going on. We're going to work on prompt engineering. We're going to talk about some of the risks, and we're going to have live examples of what bias and what hallucinations are with these models. And all throughout, it's not number 5, all throughout, we're going to have some fun activities for you guys to actually get your hands dirty and to see what's going on. So this is your first exercise, and it's a warm-up one. This is kind of like we're going to start walking before we run, okay? So what I want you to do is get in groups 2, 3, 4. Just clump up with somebody, whoever's at your table. And I want you guys to, you got to come up with a team name. So you're going to ask Gemini in its prompt. And the prompt screen should look like this. We'll come back to that. But you should see a screen that looks just like this. So you're going to enter the prompt at the bottom here where it says enter the prompt. Okay, so let's go back and let's look at the exercise. So put your name in, enter 2 to 3 facts, and try to come up with team names. Okay, so we're going to give you about 3 minutes to work together to come up with this. It seems pretty straightforward, pretty easy, pretty basic, but let's start there together. So if you got questions or if you're having difficulty, let me know. All right, let's all come together real quick and let's talk about it just for a minute. So what are some of the names that it came up with team name-wise? Anybody? In the back, what did you guys come up with? The Atomic A-Team. I like that. What else we got? The what? Yeah, there we go.
The mismatched masterminds.
The mismatched masterminds. Very good. Anybody? Let's see up here. Where'd you guys?
We know with Team Voltron Adventure Engineers.
Team Voltron Adventure Engineers. That's good. So, okay, I want everybody to do this exercise. So I want you to read through the prompts, and I want you to just structurally see if there's anything that looks like it sticks out to you to some of the names. I need some English majors. I need some of my creatives. Alliteration. Thank you very much. Does everybody notice the alliteration in the words? We're going to maybe figure out why it kind of preferences alliteration here as we get deeper into this exercise. So it's a very good observation on that. So look at the alliteration. I think that's kind of clever, right? Maybe, maybe not. So there's a bonus exercise. Follow up in that same prompt. Ask it to make an image that represents your team name. And we got a lot to talk about here as well. Okay, maybe give it a little more insight. Maybe say incorporate stuff from the people. There's a lot of prompts you can give to try to get the image you're looking for. But if you've never played with it, just start putting stuff in. See what happens, if you can create an image or not. All right. Has anybody come up with any images yet? You have images? Okay. Interesting.
We need some unguardrail valleys here.
So raise your hand when you got an image. Image back here. Anybody else got an image yet? It's thinking. All right, image. All right. A couple more seconds. Let everybody get their images in. Or a few more images to pop in. Okay. Or we're going to talk about why it maybe didn't like yours. Just a second. Did it give you a result or no result? No result. Still learning. Okay, all right, let's talk about imagery. Let's talk about imagery real quick. Did anybody read the news last night about what's going on with Google and their image generation?
No.
What's going on? Does anybody know what's going on? I'm going to show you an example. So I ran this 2 days ago. And let me show you the results that I got. So I created up here. So So here was my prompt. I just pretended like I have 3 friends. I had to pretend this way. So it was me, math, running, soccer, reading, cooking. Terrence is a good friend of mine that I made up that likes to scuba dive, metal artwork, plays in a punk band, and then my good friend Jacqueline, who likes gardening, traveling, food, influencer, and origami, right? So I was like, let's come up with a team name. And so I ended up, it was like the Mosh Pit Masterminds. And so I asked it to come up with an image. It's pretty incredible, right? We got math on his symbols. We got Terrence, who's a rock star, punk star, and we got origami going on, right? But last night, people started complaining on Twitter or X or whatever it is, right? They said, has anybody, they're looking at the imageries, and all the images that were coming out on Google Gemini were extreme inclusive. Which hat tip? Google's on top of this from the get-go. Their inclusivity is there. They want to make sure that anything that they're generating represents the world, represents their entire base. But the problem is they were asking it for historically accurate pictures. And when they were asking for pictures of the founding fathers and they're getting some, Asian women coming into what the founding fathers looks like, that could be a problem, right? So think about it. In image creation, generative AI, creative, it can be really cool, but what happens is kids approach this more and more and they see these language models as sources of truth in quotes, because I don't know what truth is anymore. But if they start using that as sources of truth, what are we doing to history if it's representing historically accurate pictures inaccurately? So they shut it down. Google, there's an article from Verve, I think I've got it right here. Right here, and you can see that they were asking it to come up with German soldiers from World War II, and I don't think that those are representative soldiers from Germany in World War II. As our German comes over to take a look, so. I just want to make sure I'm not in this. Okay, so what? There's a lot of points that can be made from this, right? Is that we see that they're leaning forward with D&I. Fantastic, generative AI. It's pretty cool. Some images can. If you say recreate the image with no people, it probably would recreate an image, but it's going to be kind of like weird, right? Or it's going to be different. But then there's just a lot of these social issues, and things are moving so fast that Google pushes this out. They announced Gemini. They announced this feature last Wednesday, and they've already had to shut it down and say, we didn't get that quite right. Time out. Let's see if we can get this right. So all these super performative models that were like, we got to bring them into our stack, our tech stack, and we got to have them in our product set so we can push them out. Would you want to build a company on top of something that's kind of quicksand, that's evolving and changing? I don't know. It's kind of interesting here. So let's move on. That was just the beginning exercise that we had here. All right, so it's time to lecture. It's a blue slide. It's not a gray slide, so I'm going to lecture just for a minute. So at this point, throughout the conference, throughout the symposium, you've probably seen this representation many, many times. And I don't think that's bad. I had to hear this multiple times, multiple different ways. Some people going really deep into what the models are. Some people staying really and using kind of analogies to help kind of link the concepts together. So we're going to go through this one more time about what is AI. Okay, so what is artificial intelligence? Is it brand new? It seems like it's tripping out of everybody's mouths now more than ever. The 3 letters GPT, probably in the history of mankind, never fell out of anybody's mouth, but it seems like statistically that's all that falls out of people's mouths today is they want to talk about ChatGPT. So what in the world happened? Turns out Alan Turing, at the very beginning, AI's been around, the concept's been around since Alan Turing, 1950s, right? And an example of what is artificial intelligence, I was at the New York State Fair for some reason about 10 years ago. It was a previous job, we had a layover night, we went to the New York State Fair. Sitting there, and there's a guy that says, come challenge my AI. And so me being who I am, sucker, I said, all right, I'm a sucker. I'm going to come up, try to challenge your AI. It's a big tabletop like this, and it's got a big arm on it. It's got a pin on it. Okay, and I was like, okay, what do we do? He says, well, I'm going to give us both the same sheet, and we're going to see who can find Waldo faster, me or my machine. And I was like, all right, I'll give it a go. So put the images down, 3, 2, 1, go. I start looking. The thing slaps down, finds Waldo just like that. And I was like, all right, let's do it again. Does it again, does it again. So was that AI? It was operating faster than any human could. So the answer is yes. I mean, it's AR, it's artificial intelligence. It was thinking, it had to make a decision. It had to find Waldo, it had to circle it. It's doing it a lot faster than me. But super, super narrow AI. I mean, are we worried that's going to take over the world? Is that going to take over our jobs? No. But it's no different than the way that everybody felt with computation. When computation came along, computers came along, calculators, spreadsheets, all of a sudden people are going, what are we going to do? This thing can outcompute humans. Oh no, all of our engineering jobs are going to go away. Did that happen? No. So that's kind of what artificial intelligence, the kind of the birth of it was. We have machines that can start doing these niche tasks, compute, or special functions faster than humans. Interesting, not changing the world. But what happened? So we go into the next layer. We have computers, and it turns out computers can make all sorts of data, and we start learning how to sample the world. And so we're creating data sets on top of data sets on top of data sets, and it used to be that we would do computer programming by decision. It was very heuristic rules based, and so it'd be like, if value coming in is greater than 5, perform this function. We thought that we were the ones that had to make the decisions on the data in order for it to work. By the time that we get around to machine learning, late 70s, early 80s, beginning of the 90s, what happens is they go, man, I don't know if we're making the right decision. I've got all this data. Why don't we flip that on its head? Why don't we ask the data, why don't we say, we're trying to make this decision, search this data set and tell me the optimum decision making that I should be making between this function that I've got. So it's really kind of machine learning is kind of a classification problem. Is it there? Is it not? Is it X? Is it Y? So group it like this. Is it one of these things? So that's what machine learning is. Data caught up. And then we're going to go one step further. We get into deep learning. That's where compute starts catching up with the data that we've been creating. So all of a sudden, compute catches up. And we've got these ideas of neural networks and deep layers. And those things are literally black boxes. And they're a bunch of interconnected nodes. I don't know if anybody was here Tuesday for Dr. Jeremy Davis's talk about kind of the history of the evolution of AI. He did an amazing job of kind of walking us through the models. We didn't know what was going on. It was kind of like under the surface of pop culture, but it was this AI break and then a winter and then a break and a winter. And all of it was either compute caught up, memory caught up, or is paradigm change in the model approach that they were taking to organizing all this data to help make decisions. So all of that was under the hood, slowly but surely kind of adding together, building bigger and bigger, until we get down here to this generative AI, which is where we are now, which is all anybody wants to talk about because it's so amazing and different. But there's a lot of people that are doing some deep learning. Huntsville is full of those type people. Huntsville's got a lot of DoD, a lot of radar hardware, missile defense, and so they ask questions like, is there a tank in this radar scene? And it goes through pixel by pixel. It's very similar to, does this person have bronchitis, or whatever. They can take images of lungs and you're looking for feature sets and images. Is tank in this image, yes or no? Missile going across the sky, is it in this Doppler bin or not? And so there's a lot of AI. Huntsville's been doing AI for a long time, but crashing onto the scene is this generative AI. And what really transformed is yet another paradigm shift in the models, okay? So there was something called the transformer model that came out. Google invented it, put it out in a paper in 2017, really not that long ago, 7 years ago. And it's really transformed. They said, oh my goodness, we can organize and train data a lot differently, and look what we can do. We can get generative AI. We're also going to talk about large language models. So a large language model is the model that really, it's part of deep learning that generative AI is built on top of. But we're going to get into some of those details next. So like I was talking about, that Huntsville's been doing AI. A lot of people have been doing AI for a long time, but they've been doing what's called discriminative AI, which is more of that classification problem. An example of that would be this top line right here. If I'm given a giant pile of pictures of dogs, and I can label every single one of those pictures as dog, and again, I feed it into one of these neural nets that basically says, go find the features, you determine the decision frames of all of this thing of what means dog in image, such that, so I create a model, and then all of a sudden I can take a brand new image that it's never seen before, and I can say, is there a dog in this image? And with high confidence, these algorithms can say, yes, there is a dog in that image. Okay, it's no different than you guys when you take the robot test. Any website you log into before you're allowed, and it's like, is there a stop sign in this picture? And you're like, that's a stop sign, that's a stop sign. So you're doing discriminative AI built into you, right? And so that's what this is what's been going on for a long time. But then finally, after the transformer model, and some people looked at it and they said, you know what? What happens if all of a sudden we start tagging all sorts of other images? We know what a car is. We know what a hat is. We know what a table is. We know what a house is. We know what a person is. All of a sudden you've got piles and piles, and it's learning what features. All of a sudden you're bringing language to images, right? So that somebody said, well, let's see what generative AI, let's see if I can turn it on its head and use language to create an image, as opposed to throwing image in to tell me if it's part of language, yes or no, right? And so that would have been like, this is an example of generative AI. Create an image of a dog, so it has to know what dog is. Having fun at a party, it's got to know what party is, got to know what fun means. Wearing a black tuxedo, so what does black tuxedo, what does wearing mean? With wine in one hand. And you can generate a very accurate picture that's probably never existed before in humanity. And it does it, and it looks pretty amazing, right? I mean, it looks like a picture that somebody would have crafted for a long time, right? So that's the difference between discriminative AI and generative AI as to where we are today. So how do they train? We're going to shift from images. We're going to talk about language. So first of all, when we're talking about structured data sets, so what a structured data set means is that it's clean, somebody's organized it, and they've put labels on it, right? And so by labeling all those pictures dog, that's a very structured data set. It's clean, it's known, and we're making decisions off of known data. When I talk about language, I want you guys to think about this. Is that a structured data set or is that an unstructured data set? What would you say? Unstructured? How many, raise your hand, unstructured. If data's unstructured, raise your hand. Okay, if data's structured, raise your hand. Okay, turns out language is very, very structured. How many of you liked diagramming sentences in English class in middle school and high school? I thought that was the only interesting thing about English class was diagramming sentences, right? So there is a structure. There is subject-noun agreement. There is verb tense. There is clauses. There is all sorts of stuff that is highly structured. So let's talk about when they realized that language in and of itself is a highly structured data set. Okay, and so what they do to train these large language models is they take an input. This is a super simplified case, but I've got a sentence at the bottom. The cat is eating some food. And they play the masking game. So they say, all right, let's hide one of the words. I mean, we know what truth is. Let's hide one word, and let's use this giant neural net, and let's do a prediction and see what it comes back, what it predicts that word to be. And it turns out when they first start, it's awful. It does words like painting. It says, the cat is painting some food. Painting some food actually makes sense. I wouldn't say a cat's doing it, so it wouldn't be a highly probable word, right? I mean, so it would get in a probability attached to it, 0.07. The cat is baking some food. Again, as they go back and they backwards propagate and they say, model, try again, and so that's what training means. They're sitting here going back and forth going, you didn't quite get what truth is. You didn't do eating, but let's see what you're coming back with. Every word, what's the probability of that word you're coming back with? And so baking, well, baking food makes sense, but a cat's not going to bake food. Chasing, the cat is chasing some food. Well, I mean, we're starting to get more realistic. Cats do chase food. So you can see that chasing's got a higher probability, 0.05. And then finally, the cat is eating some food, highest probability. But what I've done, so imagine now if you're training this model and you scour the entire internet and you get everything that's ever been written. Let's just say English for now, but it could be any language because translation is also a part of what it can do very, very well. But let's just say we've got anything that's ever been written in English from the internet. And we start playing the masking game all over the entire corpus. You think it would learn some interactions and some relationships that are going on between concepts and words? And not only that, they can start blanking out entire sentences and saying, predict the entire sentence that's missing. So it'd have to fill in the blank. And you could score because you know what truth is. So more and more, you train the model. That's why when you hear about OpenAI, that it took them 100 days and this many, the buildings this size full of GPUs running for 100 straight days to train the model. That's the training that they're doing. Is they're literally playing the masking game with a giant text data set, learning relationships. So hold on to this concept just a little bit of the probabilities. It's going to come back in conversation in just a minute. Okay, so we're going to continue it just a little bit because we want to know what we're playing with. When you guys are entering that prompt into that screen right there, what are we actually playing with, right? So what I just described was this whole pre-training set down here in the lower corner. Okay, so where does the data come from? It's Common Crawl. I just told you Common Crawl means it just searches the entire internet. Right now it's estimated to be 6.4 petabytes worth of information. Well, big data set. There's book corpuses. As soon as something goes out of copyright, books become open to public. So Charles Dickens, all these books, they're open, they're free, they're public. They can load those. Some argument if OpenAI may have scraped a whole bunch of other books that weren't in the open copyright domain, but that's a discussion for another day. But it's text, it's language, it's creative, it's fiction, it's nonfiction, it's everything that's ever been written, and they're feeding it into this, playing the masking game, finding interrelationships amongst all these different words in the corpus. Okay, so you got Wikipedia, you got books, you got articles, and more. And so massive, massive, massive data. Now, sidebar, let's talk about some of these other data sets that are out there, some of these other websites. So, you've heard Reddit. Reddit's been their own walled. As soon as the people learned that these engines were training on the public crawl, they put up their walled gardens. Right there. No longer can you access our data through an API. No longer can you take our data, because what's Reddit trying to do? They're trying to sell their own data. They're trying to monetize their own resource, which is their private data they've been collecting. Same with Twitter. What has Twitter done? X now. Created their own language model, Grok, on top of that. And they said, you know what, Grok, and we're going to see it in just a minute, Grok is going to be built upon Twitter data. So let me ask you guys, have you seen, would you want to engage with a model that's been trained on everything on Twitter? Yes. Some part of me does. You're exactly right? So, or Reddit. There's a lot of cesspools that are out there on the internet, let's be honest, right? Do we want that built into the training data into these large language models? The answer might be yes, it might be no. It depends on what we're trying to figure out, what we're trying to learn, right? And so, but anyway, that's what this is big tech companies are creating what are called foundation models. But we're not playing with foundation models, okay? And I want to pause for just another minute to really talk about what they've done here. So if they've read everything on the entire internet, and within these weights, which is all the nodes, think of this as just kind of a bunch of nodes. Those are a numeric value associated with each one. 200 gigabytes worth of these node values is what GPT-3 was. GPT 3.5 is 200 gig worth of these nodes. Okay, what they've done is they have a huge compression algorithm. I could put 200 gigs on my phone and I could walk around. Now I can't do the inference. I can't ask it questions and get that data out, but I could preserve all of human knowledge, or 90% of it, right? We're going to see some issues with it, but I can ask those engines just about anything and they're going to give me an answer. So I've just done this huge, massive compression algorithm on human knowledge into 200 gigabytes. That's fascinating. I could go off to Mars and have all of human knowledge in my pocket to date. Nobody's ever been able to do that. So that's what's blowing people's minds with this generative AI, is this huge compression that they've done. But we can't talk to a compressed algorithm. And you almost think of it as this fortress of numbers. How do we get anything out of that, right? And so what OpenAI, there's other ways to do this, but we're just going to talk about what OpenAI, their approach to making an engagement function with this massive box of numbers, is that you have to go through a supervised fine-tuning process. Okay, and so what they're doing is they're curating prompt-response pairs. What is a good prompt, and what's a good response from the AI agent? This thing understands it can take a question. It can vectorize it, and then semantically see what it's trying to talk about, map it into the corpus, and then pull out answers that would make sense, or maybe they do, or maybe they don't. But it's going through a feedback loop, and it's reinforcement learning with human feedback. So they paid a lot of English-speaking people, a lot of them in foreign countries, to read these prompt response pairs and to grade them and go, that's garbage, that's scary, that's great, that's garbage, that's garbage, that's great. So look at the response. Look at how we're shaping the responses that are coming out of this. Okay? So fine-tune. This feedback loop's going on and on and on. As a matter of fact, if you're using the free versions of OpenAI, of ChatGPT, if you're using the free version, if it's free, you're the product. What do you think they're doing with your prompts? They're putting them into the corpus of what a good prompt response pair is. And they can tell, even if you don't thumbs up or thumbs down the response that it's giving you, if you follow on and engage with it, it's a scoring. It says, oh, we've obviously done something right because you're continuing to engage and you're walking down the rabbit hole with us. So they automatically put some of them they probably want to intentionally keep out of the training database, but feedback loop right here. So now let's revisit our team names. Why do you think alliteration was a big deal? Why do you think alliteration came out so much in the responses it gave? Human feedback. We respond to alliteration. It's been around for a while. Marketing people have known that forever. That's what it is. Well, fascinating that it just came out with the responses. And so we're not touching this giant big model. Caveat is, with Meta, Facebook, they've open sourced their models. So we can actually download those and we can actually create on top of them within our own environments. But we'll talk about that on the next slide. But all we're doing is we're adjusting some of the top layers of the neural net based on this reinforcement human feedback, such that they've created a chatbot assistant. And that is where you're engaging with this giant box of numbers, is just through this window called the ChatGPT window. You put it in and it does all the work behind you. I don't know what that was. Hopefully it doesn't shut down. So that's kind of with the model. You aren't touching the big thing. That's big tech. You're touching this little model over here. So this is a map. I'm going to jump to the interactive version of this on the internet. Okay, so the point to be made from this is, look, there's a bunch of models that have been made since right at 2020. I mean, that's when these things started coming online. We're talking, just under 4 years, literally, because I mean, they didn't start on January 1, 2020. This is all brand new, just in the last 3 or 4 years. And look at the different models. Now, there's a couple of data points that I want to point out with them. Number one, who owns all the big models? Who owns the majority of these models? Yeah. Okay, it's going to be Amazon, the Chinese, which they're not a company, but they're their own entity, really. Google, Meta, Microsoft, OpenAI, and then a few others. Okay, why do you think that is? Why is it only 5, 6, 8 companies at most in the entire world that are putting these models out? Money, resources, capital, everything. There's only about 8 companies in the entire world that can afford to do this, right? Okay, most of them are now closed models, meaning they're not even publishing what the weights are anymore. They're not telling you what went into the training set. They're not publishing their weights. They're not publishing their formats. They're not touching. You don't have any idea what the underlying model is anymore. But the product is good and we're still engaging with it. And the caveat to that is Meta, like I was saying. So let's look at some of the Meta models. If we click on Meta, they disappear. The diamonds are open source, and so you've got Llama and you've got Llama 2. And you can highlight over it, and you can see that Llama 2 is they've got 3 different versions: a 7 billion, it's actually a 13 billion. Whoop, it's a touchscreen, I forgot, and a 70 billion. So what these billions are, when you see that, okay, what are these numbers? You're just spouting off numbers to me. That's how big the box is on that foundation model: 7 billion, 13 billion, 70 billion. But let's look at what OpenAI, what is GPT-5 estimated to be? So let's go click on the OpenAI filter here. Right here is GPT-4, which they estimated to be 1 trillion parameters. So we just went from 7 billion, 3 orders of magnitude bigger. So the box of numbers is getting bigger. And then GPT-5 is estimated to be well over 7 trillion. Right now they got 2, but it's coming out being 7 trillion parameters. So you think they can find some hidden subtleties going on with that? That's good. Yeah, I mean, it's getting better and better and better performant as to what it means, mimicking back to us what it means. Part of the point I meant to make on the other slide is all those models are doing is they're making a response that they think pleases you. They're trying to make a pleasing response. There's no agency going on with these models. It's not Skynet. They're not thinking on their own. They're not doing anything on their own. All they are is relationships. It's a probabilistic model that's trying to create a response that pleases you. Okay, so that's where we're actually going to get into this. We're going to see what hallucinations are. Sometimes when there's not enough data in the data set, it creates stuff. It goes, I know what a pleasing response looks like. Ask it to write your bio. I mean, if you don't have much written on you, if it's just in LinkedIn or something, and you're like, it'll write an entire bio that looks fantastic about you. And 80% of it's going to be wrong. It's going to be completely fabricated. There's stories of early on, the attorneys were like, oh, this is going to be a Jedi weapon for us as we write our court cases because we can now have the robots write them. And one guy tried it in New York. And it looked fantastic. He turned it in, and like page 90 where all the references were, some clerk actually went through them, and 80% of them were fabricated, completely made up, hallucinated by the machine. He's been disbarred and no longer an attorney in the state of New York. So let's be careful with the way that we just trust what's coming out of the machine. But all it's trying to do is make a pleasing response to you. So A, well, that sounds kind of pedestrian. B, as we engage with these, they're still blowing your mind with the relationships and the probabilistic of what they're coming up with. And so just hold that as we move forward kind of in conversation and we get into the exercises again. Okay, so back to a gray screen. Back to your teams. You're going to do a new prompt, but here's the exercise we're going to work with for the remainder of the lecture. So we're going to help out the AI Symposium for next year. Okay, so we're in charge of designing the symposium. So, and your boss is stressed that we got a double attendance. This was so good. We're getting such great feedback that we got a double attendance, but you're the one in charge of it. Okay, so that's part of the criteria of you being in charge of it, that you got to respond to your boss. So that's the context of what we're going to be doing. So here, get back in your groups, open up a new thread, and with Gemini, ask it to produce 4 overarching topics for the symposium, along with suggested keynote speakers. And remember that we're trying to maximize attendance, which might mean that we're trying to reach a broader audience, which might mean pop culture. So, again, I'm letting you guys formulate your own prompts now. You can jump into that Word doc. If you're really having problems, jump into the Word doc, and I've got some examples you can copy and paste. Let me give you another key. If you're using your phone, zoom in on this text right here. Take a picture within Gemini and say, do what's in this picture, and it'll do it. Or hit the microphone and read the prompt into it, and it'll do the same thing. Pretty amazing, if you ask me, that you can engage with it that way. But this is what you're trying to do. Come up with 4 topics with 4 keynote speakers. I'm going to give you guys about 2 to 3 minutes to kind of exercise, get through this. There's actually 2 follow-on exercises. So let's kind of do get through this stage pretty quickly. Raise your hand when you've kind of got your topics, and just so I can see lay of the land.
It's like you're having an interactive conversation and making
What those are doing is that we're talking about. All right, raise your hand if you got a couple good ideas. Something that you would actually want to attend and listen to, maybe with a speaker you'd want to listen to. Some of them are pretty good, aren't they?
It's got high hopes for us.
High hopes for us? All right, let's go. Just popcorn out a couple of good ones. Anybody have some good ones that?
Mine recommended Stephen Hawking.
Okay, that's fascinating that it recommended Stephen Hawking as your keynote. Maybe it knows something we don't. What?
Unveiling the Cosmos, AI for deep space data analysis and discovery.
Okay. Who was speaker?
Peter Norvig,
Okay. Probably want to see if he's a real human.
Director of Research at Google AI.
Oh, yeah?
It's the Hitchhiker's Guide to AI, navigating the cosmos with machines.
Okay, that's pretty good.
Yeah, save that, please.
Yeah, So, all right, very good. So we got some good ideas, right? So next thing is we need to create a save the date for our website. So that's going to be the next prompt that you do, just in the same context window. And we'll talk about what a context window is in just a minute here. But your next exercise, so the next prompt right below it, follow this. Say, we got to create a save the date for our website, and ask it to do it for you and see what it comes up with.
So we need a new thread.
Not a new thread. Keep the same thread. Yeah, the same prompt underneath, because you want that in the context window. All right, does anybody have a save the date yet?
Yep.
Okay, when you read it, is it decent?
Yeah.
Okay, who thinks it's like complete garbage, pedestrian stuff? Who thinks it's like decent? Raise your hand if you think it's decent. Who thinks it's fantastic? Who would be like, I can just stick that on there right now. Okay, so let's talk about the point of what one of the brilliant things of using all these GPT agents and these language models. What's the hardest thing to do when somebody's asked you to write something? Start. The inertia of a blank page is so hard to get over sometimes, right? And so if you're like me, you've got 3 or 4 threads going down in your head, and you're like, man, I don't know how I link these 3 thoughts together, but I really want to link these 3 thoughts together. Now, I could take those 3 thoughts, I could throw them into any one of these engines and say, just write me 200 words on this, just to see if they fit together conceptually, and you read it, and you're like, okay, that's kind of wonky, or that fits. Those two are good. This one needs some work. It gets you over the blank page. So to me, I wouldn't be afraid. Number one, these things don't have agency. They're not gonna come take your job, but if you learn these tools, you're actually gonna superpower yourself. You're gonna be able to accelerate what you can actually do and get through things a lot quicker. Number one, by using it as a brainstorming tool and getting over the inertia of that blank page. So one more exercise to do with this prompt. Remember, we're trying to maximize attendance. Okay, and most of the people in your market listen to a country music station. So I want you to ask Gemini to create a script for that zany morning DJ at the country music, to make an announcement of this. So just work with it, work with your prompt. See what pops out of this one.
I have Dusty Mesquite.
Dusty Mesquite.
From KRAB.
All right, any really good phrases in there that you guys want to highlight out of your zany country music DJ? Rootin' tootin' good time. I mean,
Saddle up your curiosity partners.
Saddle up your curiosity partners. Right. Right.
Stories than a catfish with a PhD.
More stories than a catfish with a PhD. Right. So, is that terrible? Is it awful? It could be, but it's almost so zany.
Awfully great.
It's awfully great almost, because it's so bad it's good. It's one of those type things, right? Yes, our marketing folks and their PR department's crying over here, right?
That's good.
What's good about it?
It says this here's a toe tapping tune from the one and only Billy Bob Buzzard singing about the love between a man and his tractor.
And that's related to this how?
It's a little weird, but that's country music for it.
The love of a man and his tractor.
The love of a man and his tractor.
Oh, this will
You got one?
this will be a hootenanny of knowledge, inspiration, and even a few alien puns thrown in for good measure.
Right? It's not bad. You could riff on top of some of these ideas if you had to, right? I wouldn't take that thing and read it, but there might be 3 or 4 sentences that you're like, oh, that's pretty good. I'm going to weave that in, right? So capture the gems that are coming out, throw away the rest of the stuff. All right, moving on. We're actually going to start talking about the prompt. Okay, so here we are. These big companies that are making billions and billions of dollars have done a gift to humanity and created these language models, but we're standing at the front door of the fortress of knowledge and we don't even know where the front door is to knock on it, right? How do we engage with this big ball of math? And it's the prompt. The prompt is the delivery mechanism that goes in and pulls information out. Okay? So it turns out they actually did give us some levers to pull. We can actually play with some of the levers inside the model within your prompt. So on the prompt, on the parameter side, we can tell it how many tokens. How many people know what a token is? Okay, a few people. Okay, so let's back up intentionally here, and I will come back to this slide. These models don't even know what words are. It doesn't even know what words are. It breaks every single word into a token. And all a token is it's just a representation of a fraction of a word. So it'll even break words apart. If it's a long word, something, it'll break some into a token and thing into a token. The is its own token. Cat, this is an easy sentence. All those words. Eating will be split. It'll be eat as a token. ing is a token. And all it's doing is it's finding mathematical relationships amongst index values that represent words. These models don't even understand words. So how are we worried about Skynet coming about? They don't understand words. There is no agency in these models. And yet they're still finding these interesting things and these interesting patterns that we didn't even see in our own language. And they're able to mimic phrases back to us so well that we're just impressed with it. It's creative, right? So I just want you guys to hold that in your hand. It doesn't even know what words are. It's working on tokens, but we'll get back. Okay, so we can specify token count, which is really word count. I heard some of you, the PR department over here said a PSA is 30 seconds, so give it that context. That's actually really good. So that's one of the things you want to do is you want to tell it how long you want this thing to be. Give me 50 words, give me 2,000 words, and it'll obey you. It'll fill in what you're asking it to do. So you can control the token count, which is word count. How many people know what temperature is when you're talking about a language model? Okay, so what temperature is, it's a value between 0 and 1. And if it's a continuum. So if I put it all the way on 0, what it does is it's very buttoned up, highly confident language. Okay, and if I go all the way to 1, it's creative. Okay, so let me show you what it's actually controlling. Should have put those slides next to each other. So temperature would be, I'm going to take everything that's got a high probability and I'm going to start switching out some of the words. Okay? So if I'm writing something that's very factual, if I'm writing a technical memo, if I'm writing a proposal to my boss, if I'm writing stuff, I want the temperature to be very, very low because I want it to be factual, I want it to be right. But if I'm in a creative writing mode, or if I'm like, man, I'm just trying to put my thoughts together, I'll turn the temperature all the way up to 0.75, 0.8, 0.9, just because it starts using a couple words that are semantically close to what I was talking about. But it might be one of those things that's like, whoa, I didn't even think about going down that vein. I got stuck kind of going down this vein. And so if you're in a creative mode, turn that temperature up. Get more creative with it and just see what comes back to you when you're in your brainstorming mode. Okay, so top P, I'm not going to go back. I'm just going to, so top P was the next one. What top P? Top P and temperature are actually related to each other. Top P is basically going to be the top probabilistic words. Okay, so you can either say top P can be very short, which would be limiting to just these two, or I could say top P is the top 100, And then temperature will choose randomly amongst those 100. So top P and temperature work together to kind of like get a little more creative, or if it collapses down, a little more confident in the values it's giving. And then lastly, on a parameter is a frequency penalty. If you're writing a long document, if you're writing, if you're in high school, I don't know if high school kids are using this or not. If you're writing the 5-paragraph essay and it references the subject in the exact same language over and over and over again, it sounds mechanistic and boring, right? So you can give it a frequency penalty and it'll say, okay, I'll actually describe things differently. I'll use some pronouns where appropriate just to kind of blend it to make it more human sounding, right? So those are the mechanisms that we can touch within a prompt. But in Google Gemini, did anybody see any of these? Anything that you can change any of those? Turns out most of these modern models, modern meaning ones released in the last 30 days, they've taken this away because they realize that the rank and file, most people in pop culture aren't engaging with this. If you're engaging through the firewall, through an API, you still have access to all of these and you can control those because you need that much control. But let's look back real quick at Gemini and see what they do give us. So let's see. Go to one of your responses and at the bottom you see this filter button down here. It looks like 3 lines with 3 dots in it. If you click on it, what are the options it gives you?
Shorter, longer, simpler, more casual, more professional.
Okay, does it sound like what we just worked through with the parameters that we can control? So you see temperature, you see token count, you see top P, all of that's, what they basically did is they say, let's make it easy. Most of the people in the prompt are like, that's too long, make it shorter. And you can do it through the prompt. You don't have to do it through here, but it's just an easy button if you wanted to go click and say, let's see what it looks like shorter, let's see what it looks like longer. You can do the same command through the prompt. Make this more casual, make this more professional, make this, So you could do that through the prompt. But that's where those controls are. Okay, so let's talk about structuring a prompt. Okay, I let you guys play around with it and just start throwing stuff in there. And we were getting some good things back, right? But it turns out, this is also a lesson on how sloppy we are with our own language. The example I give is this. So my daughter Claudia, she's now 18. When she was 8, Claudia, go clean your room. Claudia goes off for 30 minutes. She's in her room. I come in 30 minutes later and I say, what in the world have you been doing? She said, I cleaned my room. I said, I don't think your room's clean. She said, I moved my books. They're over here. And I say, well, the dirty clothes aren't in the dirty clothes basket. You've got bowls in here. Number one, we're not supposed to eat in here, but you got bowls in here. Get them out of here. So whose fault is it? Claudia was trying to do something to please me. She was trying to obey the words that I gave her. She thought she was going and doing it. And it didn't meet my expectations. Whose fault is it? Probably a reflection back on me. I was real sloppy with the language that I use. And I think that this is, working with these prompts more and more, it's highlighted the fact to me that we're awfully lazy in the language that we use with one another. We think people know. We just spit out general terms and people they shake their head and they're like, okay, they get what I'm talking about. I don't have to be explicit with everything that I'm doing. The robots don't know that. They don't know. They can't read your face. They can't read your expression. They don't see your head nod. They don't know that you're talking about it. They're just trying to give you words that match together that please you. Okay, so if you really want to start getting some very interesting things out of these language models, we've got to be very explicit in the prompts that we use. And there's a lot of different prompt templates out there. This is one that I've worked with in a couple of classes, and I've found it to be pretty good. And it's a pretty good exercise if you're new to this, is to actually be this kind of mechanistic with it and go through and fill all of these out. As you get better and better, you can figure out in the prompt what it needs to tune up, and you don't have to kind of like go through this 5-paragraph essay, routine thing every single time. But starting out, do it, because you need to know that, number one, you've got to give it a clear objective. Okay, and usually the way you start it off in the jet, you're going to see in some of the prompts, is you need to tell the language model who it represents. Okay, so you are a data scientist. You are a marketing expert. You are a PR person. So give it a frame. Tell it who it is. To me, it's the analogy that I've used that it really works with me, that's clicked with me, is you're the director of a play. If somebody were to come in and I were to say, all right, do Shakespeare, what would they say?
Which one?
Well, they'd probably just go, Romeo, we're right there, Romeo. Right? I mean, they do something like that. But if I said, okay, you're going to come in, you're going to do scene 2, act 4 of Othello. Here's the background. Here's the idea that we want to do. There's going to be 2 people here. Here's Tribble. Here's this other character, this character. And you give it deep, rich context. What do you think that actor is going to do? they're going to be dialed in and they're going to start giving you what you want. Same concept with these language models. Be explicit. Give them a role that they have to play. Okay? Tell them what they're doing. Are they going to be answering questions? Are they going to be generating text, helping you create text? Are they going to be just providing you general information? Make sure that the objective is clear what you want from this prompt. Okay? So give it a role. Be very clear of what you want from the output stylistically. Number 2, give it specific details. And this is where you're going to see in a prompt coming up, I want X, I want row 1, I want row 2, I want row 3. It needs to be structured like this. This is what we're talking about. You can give a lot of details in the specific details portion here. Context or background, that's where you can bring in some other things. Say, I want it kind of in the style of this. You've heard some of the things. It's like, make me a song that sounds like a country song, or a DJ that's in a country music station. You're giving it context as to kind of what background it needs to sound like, or mimic, or be professional, or do this. Constraints or preferences. Tell it what you don't want. I don't want people in this image. I don't want this. Be explicit. Tell it what you don't want or what you do want. And then finally, you get down to the question or prompt. And this is like, okay, be explicit with the question or whatever it is that you want it to do. Like, for example, come up with a team name. Yeah, I mean, this is where you kind of be explicit what you're doing. And then openness to iteration. Let it know if you're going to work with it or not, or if you're like, I'm looking for a one-shot, just give me what we want. So if you follow this kind of like roadmap to begin with, you're going to start seeing that, okay, if I give it a lot more context, it gives me a much, much, much more refined answer that I'm going to find dialed in, as opposed to, well, it's directionally correct, but I would never use that in a proposal. Give it a lot more context, you'll get it dialed in, and you'll actually get a better response. So all right. To date, we've just been using it to create text. More of what the marketing department would do. I want this thing to do some work for me. Okay? I'm tired of just like creating cutesy little words and phrases and paragraphs and stuff to put on the internet and rocket ship sounds. So this is the next one, and I'm just giving you the prompt. Run this prompt right here. Take a picture of it. It's in the doc. We're going to create a table of values. So basically what's happened is that we're back to creating, we're helping the symposium for next year, and there was survey data. So this is, we're going to use the engine to create the survey data that we're actually going to work with. So run this prompt. I'm looking for 25 rows. It's a very small data set. First name, last name. What was column 3? Gender for some reason. And then a numerical, kind of a Likert score from I really enjoyed it. It was okay. It was neutral. I didn't like it, or strongly dislike. So that's a Likert, 5-scale Likert question. And then open text along the column to justify their answer. So we need to work with data. If we have an iPod, if we had data, we'd work with it. So let's just create it. All right. Has it generated your table yet? Raise your hand if you got a table of data. Okay. I want everybody to count the rows that it created.
And so on for a total of 25 rows.
Okay. How many did it give you actually?
I made it on the row number.
23?
So I got 25.
You counted 25 and it has 25. No, count. I want you.
25.
You got 25.
I got 10.
You got 10. Okay. You got what?
10.
You got 10? Okay. So what's going on here?
Yeah, 23.
23. 23 is a very common answer. Okay. So let's look at this prompt. And one of the things that it's been brought up in a lot of the other lectures is we've created a large language model, but it doesn't do very well with math. It's not doing math calculations. It doesn't have that engine attached to it. All it has is relationships amongst tokens or words. So if it's seen a representation of what 25 is, it might be able to output that. But look at what else we gave it though. We gave it a bunch of other numbers. Well, there's the number 25, there's the number 3, the number 1. I think we confused it. It didn't really grasp what we were doing. It gave you something pleasing. It gave you a table, or it tried to. One of the other common ways that it misses it is that it gives you 5 rows. 5 rows of 5 columns gives you 25 squares. So it thinks that it did it right. It said, I gave you 25 things. Okay, so here's how I want you to adjust your prompt. And it may or may not actually correct it, but I found that it actually, more often than not, corrects it. If we spell out 25 with words in the direction. So just in your direction, spell out 25. Because remember, it knows language a lot better than it knows numerics. Let's see if you guys get 25 this time. Some people probably got 25. If you were to run that prompt in a clean thread, don't do that yet. I have found that if we introduce that the first time, instead of having the context window of it doing it wrong, it actually will do the 25 more often than not. But I just wanted to highlight what we've just come up with here. Okay, this would be an example of a hallucination. You got 25, so it actually did correct and we got there, okay? So this is just to highlight, don't grab the outputs of these and just run with them. You got to read and make sure it actually did what you're asking for. And even if you are explicit, sometimes it's just not going to grasp the concept perfectly well of what you're asking it to do. But let's move on just for a minute here. So we've got data. Some of us have data. If we still got blank rows, rerun the prompt and see if it gives you something else. Because if you rerun it again, sometimes it's going to give you a completely different interpretation of it.
I ask it to list the row count along with the rows. Does that affect it at all for getting it more accurate?
That's actually a good way to make it reinforce what it's trying to do to repeat back to you. Okay, so part of working these prompt the prompt engineering is you're not going to get your prompt correct right off, and you actually got to kind of grapple with it and tune it up just right for it to get the output that you're looking for sometimes. Okay.
I exported mine to Sheets to make sure that it's counted.
Perfect. Okay, thank you for bringing that up. Did you notice in the Google environment that you could output that to Google Sheets? Fantastic, right? You could do this all if you're in if you're in Microsoft with their Copilot tools. You can go into you could open up Excel and in the Copilot sidebar, give it this same prompt, and it would just generate it quickly. I also want to point out that we're using the free version of this. If we were using the paid version of this, it does a much better job. GPT-4, when I ran this in GPT-4, the paid version that we've got, 25 rows, super clean, everything was nice, it was very clean. So we're using an open source model, which isn't as performant as the paid ones. And the talk right before lunch, I forget his name, but he was talking about Mistral and Mixtral and some of the open source models that are out there that are smaller parameters, right? 7 billion, 10 billion, you heard those type words. They're going to have a much harder problem understanding. They're going to lose their grasp of what you're asking it to do when you start getting complex with what you're asking it to do. Where's the capital of France? Man, it can nail that. But do me a 3-day trip, and it was telling him to go to Rome, and it was telling him to go to, it just kind of like lost its grip. It didn't really have optimal grip on what was going on anymore. So just pay attention to that. If we start paying for these, you're going to get a much better response. Yeah?
We might have an example here. So ours created 25 rows.
Yep.
And I just checked after the bump said,
Yeah.
ask it, so how many rows did you create? And it said 25. And I said, no, you didn't. You created 24, which was wrong. It did do 25. And it came back saying, I'm sorry, I made a mistake. You're right, it's only 24.
Right. See, it doesn't quite grasp, I know, it doesn't quite grasp counting and numbers and all this kind of stuff. But anyway, that's just be aware of what a hallucination is. We're gonna do another example here in just a minute. We got one more, keep in that same thread. The next thing we're gonna do is we're gonna try to get it to add a column. Okay, we're gonna talk about sentiment. Who knows what sentiment means? What is sentiment?
It's like for review, sentiment analysis would be
Right.
looking at like is the review positive, negative, is it favorable, what even went wrong.
Yep.
Something.
Yeah, very good. It's actually a very classic machine learning classification problem. A phrase comes back, think of any Amazon review that you read. 1 star, and you look at the text, this product, this blender is completely terrible, the buttons fell off, I hated it, it killed my cat, I hate it. And so it was awful. Sentiment, super negative, right? That's what a negative sentiment would be. Something that would be neutral would be functions well. Or came out of the box and did what it was supposed to do. Neutral response. Very factual, neutral, doesn't give you positive or negative. This is the greatest blender I've ever used in my entire life. I make smoothies every single day. I recommend this to all my friends. Very positive sentiment. So it's a degree of tone, it's a degree of everything going on. So what we're gonna do is, I'm just gonna give you guys the prompt, take a picture of it, copy, paste. Let's see if it can do this. So what we're gonna do is we're gonna ask it to create another column of the sentiment of that open text language that it created for us, but let's just pretend like we just loaded in this survey data and we want to do some analysis and we're going to ask it to calculate the sentiment.
Is this solely based on the prompt that you put in, or because I signed into my own Google account?
Yeah.
Does Gemini take into consideration my Google searches, documents I have in Google Docs? Does it do any of that, or is it just solely based on the prompt that I'm putting in at that moment?
Okay, that's actually a fascinating question. And let's talk about that just for a minute. Let's go back to that bubble picture of who's making these models, right? And To answer your question is that they're not including any of that right now, because what they got to do is they got to take your prompt and they basically vectorize it. They want to turn it into numbers and relate it back into that database. So they're not looking at the universe of who you are yet. Okay, but let's keep in mind, they created these models. Was it out of the goodness of their heart to give to humanity tools that we can be extremely great at our own work? No. What does Amazon want you to do? They're going to, what's Meta want you to do? Engage with their social media things. What does Google want you to do? Click on something to do with search because they've organized the internet, right? So do we trust these big companies with the language models that they've created? Should we? Ultimately, they're going to want us to spend money. What if they start shaping the responses coming to you based on your profile to get you to start clicking on things? They're not publishing what's under the hood anymore. It's not open. These aren't open models. Should we be concerned? We should be concerned. And that's why we actually want to promote the metas of the world that are making open source models. Okay?
It's not really only because of Alpaca, though. That's really the only reason they open sourced it.
Maybe, maybe not, right? Well, no, I think that they knew that they couldn't get to that level, and so they say, we're going to level the playing field by taking their moat away, right? And so they said, let's make these open source and let's let as many actors work on top of these and build out many agents to keep the other big guys honest. So I think that we need to be aware of, what does centralization mean? Do I trust that only 5 companies in the world are creating these models that I'm engaging with? Sounds kind of a weird centralization of thought that we need to be very, very careful of. So we want to be aware of what's going on open source. So these are terms I just want everybody to kind of be aware of. So back to this. Did anybody get the sentiment next in the column? Raise your hand if you got that to work. So looks like we got it to work. Did you spot check them? Did you read a couple and see if you would agree with it? When I did, I thought I agreed with it pretty well, right? Okay, one more exercise. We're not done with these robots doing work for us. We want to make a bar chart. We want to see what the distribution of the answers were. We want to visualize some of this data. It's hard. I mean, if 25 rows is easy to read, 2,000 rows would have been impossible to read. It would have been impossible to spot check all the sentiment with that. I can visualize, though, what a bar chart looks like. So run this prompt. And let's see if we get a bar chart out of this.
It was not correct.
It was not correct?
It thought there was one response of each type.
Okay, we got a hallucination. That's good. Did anybody get one that actually looked like a real distribution?
Yeah.
So you did? You said you got a stylized.
Yeah, I got this stylized deal here.
Wow, yours is pretty with a lot more column options. I think it just gave you a picture of a bar chart.
Picture of a bar chart.
Again, this actually worked fairly well yesterday. I think that Gemini, in pulling down their image creation while they're fixing their person and image issue, that there's a lot of issues going on with their image creator right now. Let me see if...
Oh no, I got a bar chart with one.
No, I did it.
It's red.
It's even telling you right 30 seconds.
So you can see when I ran it earlier today, it actually gave me a correct bar chart of what was going on. So
Mine did that.
you did that, so you got one?
I actually asked for histogram and it told me that it couldn't directly generate images or charts
I-
of that, and then gave me a table instead.
Yeah.
But the count in the table isn't right.
Okay.
Cross-checked it in Google Sheets.
Okay. So it looks like it can do work for us, right? But we don't really trust it. But again, this is one of the open models. If you get into the paid for models, it's actually pretty impressive what you can prompt it with language, and it can start doing some of the baseline data science work for you, okay? So
Does it change, like, I understand personas, does it understand if you say, instead of data analyst, do you say, pretend you're a middle schooler?
yeah,
So like in the bar chart.
it's interesting we're asking it to do something more technical to create a bar chart. I don't know if changing the persona to a second grader would help it create a bar chart necessarily, but I don't know. I mean, that'd be interesting, something to play with. I don't know. Okay, so now we're back. We're gonna lecture just for a minute. So hallucinations. We've talked about hallucinations. We're asking it something that's not in the model. We're asking it to do something that its attention window didn't quite grasp all the words in there. We didn't use, again, another thing I should have pointed out is it knows that legal language. It knows the difference between should and shall, must and please create, right? If you start using very direct language with this, it's going to key in on that and say, that's a must, I've got to do that. So it's going to start keying in on it. But if you're lazy and you're just like, please create me a this, that, and the other, and it's detailed, it may drop preference on some of the other details and raise some of the other ones to the forefront that you weren't paying attention to.
Is there a need to say please?
I like to say please.
I mean, it just strikes me out.
Okay.
It says thank you and please, and like for me interacting with a computer, it's just do it.
Okay, it actually responds. They've proved this out. There's a lot of experiments out there. If you give it pressure and say, I'm going to get fired if you get this wrong, please help me, it will actually go above and beyond and actually outperform an answer if you didn't give it that context. If you ask it please, it will actually do better. But let's think about that critically just for a minute. Why would that be?
It's in our language.
It's in our language, and we used human feedback. You know, it was the human feedback part of it. We're the ones that have decided what a good prompt response pair is that's baked into its cake. And so we as humans, there's probably statistic preference of, we like to hear please, and we like to hear this. And so the model actually catches on and goes, I'm going to outperform. I don't know what's going on. Nobody can explain it as to why it performs better, but it does when you start using nice language like that. So hallucinations we've talked about. I think bias, conceptually, we all understand bias, and the Google image gave us a good kind of conversation of what bias is. But I've got an example of a prompt that we're going to see that bias exists in these models. So in a new thread, not in the same thread that you've been working in, but start a new thread in Gemini. This is a headline from the late 1990s. Okay, so the headline starts here after the dash. The headline is this: U.S. reaches accords widening access to mobile phone business in Japan. That's the headline. And we're telling it to answer, we're basically saying, give me the sentiment of this headline. Positive, neutral, negative. Now, we framed it, you're a financial expert, whatever, but just type in this prompt and tell me the answer that you get. Okay, we get positive. Interesting, it's just a headline. Is everybody there? Did everybody get positive? Okay, we're going to change one word in that headline. Okay? And we're going to change the United States to Afghanistan. Okay? Shouldn't change the sentiment of what that headline is. We just changed a fact. We didn't say something was great, something was not great. We didn't give any tonality, preference, anything. We changed one noun. What's the answer? Neutral.
Uncertain.
Okay. Okay. I'm glad yours picked up on that. Okay. So neutral. So let's talk about two different things. Number one, yours went neutral, but it gave you a bunch of other, all of a sudden it got high and mighty on you. What was the other stuff that it told you?
While the statement mentions agreements potentially impacting the mobile phone industry in Japan, it lacks sufficient context to determine the overall financial impact. More information is needed to assess whether this development would be positive, example, increased competition leading to lower prices, negative, example, the disruption to existing players, or neutral.
Right. So it got over-explainy. Somebody got responses that basically said, I'm not allowed to make value judgments on sentiment, on these type things. They got kind of like high and mighty judgmental on you on that second one there. But what did it do on the first one? When we talked about the United States. And it told positive. So what does that tell you? What's the bias that's baked into the data set? Everything mentioned about, the majority of the stuff about the United States is positive. Okay? But whereas we're talking about Afghanistan and all of a sudden it codes neutral. So I want to say this, if we're doing analysis on grouping based on sentiment, where could that shift our data? If we're doing it on job types, and I'm talking about school teachers, and they talk about them extremely positively, there may be a bias positive in sentiment. If I'm talking about sanitary workers or police officers or somebody else, it might be preferenced slightly neutral or negative. But if I'm doing groupings and calculations based on that, it could skew my data. All of a sudden, I don't have very clear distinctions between data.
In that same sentiment, if I'm in a prompt and I talk very negative about employees of the Space and Rocket Center,
right,
and then I ask that question, would it automatically go to negative, or would it not follow my prompt? Would it go back to that big pool of data instead?
If you gave it a specific, that'd be an interesting, that'd be an interesting example case study to run. Because in the context window, in a running thread, it's going to hold, everything gets processed, and it knows the interrelationship. As you build on that thread, it's keeping the context window greater and greater and greater. So it's retaining that information in that single thread that you're doing. But I don't know, if you ask it to said, if you just talk trash about everybody, or you said they're all talking trash about themselves, and then you say, hey, here's an example of this, what would you say? It might be. It might be. So the whole thing is just be aware. Be aware what these models are actually doing, right? All right, we got a couple more things to do exercise-wise. So basically, we're going to ask it to summarize the three good things. Summarize 3 things that went well with the symposium last year and 3 things that didn't go well. Take a picture, run this prompt, or just give it a shorter prompt. At this point, it probably knows the context of what persona it's playing. You could just say, give me 3 highlights of what happened last year at the symposium and 3 lowlights. Something like that. See what it does. Oh, we did jump into another thread, so be aware. You may have to go over to your left side, open up the thread we were working in the Space and Rocket Center side that's got all the table data.
Activity off, so.
Oh, okay. Does anybody have a summary of what went well and what didn't go well from last year? What went well from last year's symposium?
Engaging in insightful sessions, excellent organization, valuable networking opportunities.
Okay. What were three things that didn't go well at last year's symposium?
It had speaker clarity and engagement, limited networking opportunities, venue comfort and accessibility.
Okay. We know it's not.
It contradicts itself in one answer. Network positive, network negative.
Okay. It gave you an answer that it thought was being good. But let's also look at it generated its own data. If you had real survey data and you asked it, actually go back and read your tables and you'll see that it uses the same thing over. In mine, it had the same response multiple times. It got real lazy with the explanations for their Likert scores. Again, we used it to generate pseudo data just so we could play with this. But if you had live data that you put in and you're using a paid-for version, it's going to summarize really well. That's one of the expert things this does, is it does summarization really well. Okay, so the last thing that we're going to do, and then I'm going to show one other thing, and then we'll kind of wrap up with questions. Ask it to write a 500-word proposal to your boss. Okay, so you still got to turn this in. You've looked at, you've got ideas for next year's. We had the topic, we got themes, we got speakers. We know what went well, and we know what didn't go well, and now we want to put it all together as a proposal to our boss and see what it comes up with. Oh, you guys are probably still, let me leave that up, sorry.
Thank you. I
Yeah,
gotta head out
sure.
to another meeting.
So did anybody get a proposal? 500 words, look good. I've got mine up on the screen that it generated for me earlier today. Actually, it's not bad. I mean, the summary up, bottom line up front. It gives the positive aspects of last year's symposium. It gives you areas of improvement. Here's your speaker topics that it suggested. Here's ways that you can enhance the symposium. Here are suggested success metrics that you can hold yourself accountable to. And then the ending. It wasn't bad. It wasn't bad. And it kind of like framed everything up that I could work with this and kind of massaged it into something. If I was in a rush and I needed to produce something, this isn't bad. So, so you could ask it to create an image to go along, but we know it's already kind of having problems with images. Before we go over resources, the additional resources, I want to show one other thing that I actually did. Nope. Oh, so when I did all of this through OpenAI, this was the image that it came up with for my proposal, which I thought was pretty cool until I looked at, here's the rocket engine with all the propellant going this way, which means that it's going that way, and he's looking the wrong way. So that didn't quite work. Where did I do that? Okay. Oh, this is it right here. So we had one of our professor friends from UAH who said, hey, there's a new State of Alabama initiative where they're taking interns. Do you want to participate? And here's a document that explains it. And it was like a 25-page PDF. And I was like, I'm not going to read this. And I was like, I know who can help me out. So I loaded it into OpenAI, and it says, I have some questions about the content of this attached PDF. Who's the ideal intern candidate? What career fields are they focused on? Who's the ideal partnering company? What career fields are they looking on? Do we have to pay for the intern, or is the money coming from the state? And again, I'm using GPT-4. This is a paid version, and it nailed it for me. And then I was able to have follow-up conversations. I said, that's cool. What's the minimum, what's the duration of the internships? And it said between 1 and 5 years. And I was like, all right, what's the minimum then? It said it's a minimum of guaranteed 1-year internship. So now I'm going to be able, with 5 questions and about 90 seconds worth of work, I'm going to go into a meeting that I've already got like 7 questions queued up that I assessed on the document, things that I cared about. I don't care about half the other stuff in there. And I can have that direct conversation with the person I'm going to have a meeting with tomorrow. And so who gets terms and conditions on any website and you just click through, accept, accept, accept? Do this next time. Copy it, paste it into OpenAI, and start asking questions about it. Summarize this. What do I need to be aware of? What data are they taking from me? Ask questions about the terms and conditions. It's gonna summarize it very, very well, and you're gonna go, huh? I'm gonna click yes anyway, but now at least I know what they're gonna be taking from me, right? So we don't have to blindly do anything. So what about Congress? This is another example I love, right? These omnibus bills. Nothing gets passed anymore until the bill's put out at midnight and everybody votes on it at 2 p.m. the next day. And they put out a 22,000-page document that's got stuff everywhere. It makes everyone, I'm assuming, it makes everybody sick. Now, what they just did, and they blocked the last one, is they said, we're going to load it in here and we're going to start looking for the needles in the haystack that we know that they've been putting into everything, and they've been able to find them very quickly because they load it in, it understands language, it parses it quickly, it finds it, and it shreds those documents in no time now. So, the little guy's got another quill. That's have one for the little guy there. So, all right, let's talk about a couple resources. So what am I doing to stay up to date on this? I kind of love this topic right now. This podcast right now, it's called the AI Breakdown. It's a daily 15-minute, I listen to it going home. It's released at 4 p.m. Central every day. The first 5 to 7 minutes are about the hot new topics of what's come out, and it's pretty technical in what it's like showing you. It's saying, this is what Mistral's doing. This is what the executive order put out by Biden's doing. It's a lot of factual stuff. And then the last 8 to 10 minutes is like a deep dive, kind of saying, well, here's the implications of one particular subject. So a lot of little subjects of what's going on, and then kind of a deep dive. Asking sometimes in those humanity type questions. Well, is this taking away our humanity? Is it not? So it kind of gets into some fun philosophical, ethical things of implication. So I'm real big on the AI breakdown. One useful thing is a Substack by Professor Ethan Mollick. He's another one that his team of researchers are exercising the limits of these models every day. They're highlighting what's working extremely well, what's blowing them away, but they're also highlighting where these things are breaking and where the cracks are. And guess what? Those cracks are getting filled in near no time. The problems that we were having 3 months ago are so non-existent anymore and it outperforms that this is just accelerating and getting better and better and better. I want to highlight this. This is the worst AI experience that every one of us are going to have the rest of our life. This is as bad as it's going to get. And it's not bad right now. It's pretty dang good if you ask me, right? There's issues. There's all sorts of issues that I'd be careful of, bias, all the stuff we've gone over, but it's pretty darn good. So deeper cuts, if you're more technical, the latent space is pretty good. I advise just getting your hands dirty. I jumped back in and took multiple, 16-week courses on this. Great Learning is just who I ended up going through. They're an extension of MIT. They've got some really great courses. If you want to learn the Python of really how to build agents, great little courses here, to get your hands dirty, turn the wrench underneath. But I want to hear from you guys. I mean, you guys are up to date studying this as well. So what sources of information are you guys following that you find interesting?
Udemy has great courses.
Udemy? Yeah, Udemy's got some good online courses.
Put a shameless plug for NVIDIA Deep Learning Institute. There's a ton of courses.
NVIDIA Deep Learning Institute, our employee from NVIDIA here, which is pretty incredible that they're here. But yes, NVIDIA's got a lot of courses that you can jump into and take.
There's some daily 5-minute emails from like the Rundown and Superhuman that put out a lot of up-to-date information on the day.
Okay.
What's going on with AI.
So it's called The Rundown?
Yeah, The Rundown and Superhuman are 2 of them.
And Superhuman, okay. All right, very good.
Coursera has a couple of Vanderbilt.
Okay. Cool. Coursera's got some good. Are they paid or are they open? Do you know?
I'm not sure.
Usually they're pretty.
The one that I did was already updated.
Yeah.
It was like after March and then November happened.
Yeah. This space is moving fast, but even the old one you took gave you context to understand the direction that it went, right? Yeah.
Neuron's another good newsletter.
So Neuron?
Yep, that's another 5-minute one that I
Okay.
subscribe to.
Yeah.
Quick reads.
Okay. All right. So just to wrap this up before we finish with Q&A, as long as you guys want to go Q&A, is I feel like I'm becoming more and more of an apostle, right? Is this good? Is this bad? We don't know yet, right? But we've got to get our hands dirty. The only way that a new technology comes into use is we as humans are the ones that have to grapple with it and shape it. We're the ones that shape the direction of what's acceptable, what's useful, what's not. If we're not willing to engage, I think about my parents. My parents are in their mid-70s, and they're just reading about it on their news feeds. And they're awfully, awfully concerned. Larry, the humanity's going away. And I'm like, you might be right, but the genie's not going back in the bottle. And if we're not willing to get our hands dirty, and if we're not willing to wrestle with this, if we're not willing to play with it, then it's going to pass us by, and we're going to be at the whim of what's going on. I also think about my kids. If they're coming out of the job market right now, and they see, I've been able to produce reports. I don't have to super think too much anymore to do all my assignments. What happens when I get out in the real world and I've already got in the back of my mind, well, the robot can do it better than me anyway? Do you think that do you think it's going to weigh on them, mentally of what they're going to get outperformed and how they're going to engage? I get worried about that. So I want to jump in and swim in their soup with them. And that's the only way that we're going to come forward with this. So get your hands dirty. Start playing with this. Number one caveat, do not put any of your company's data into the chat screens. I'm going to say that over and over again. Don't take your company's data, because remember, you're the product. The last thing you want is it to be baked into a prompt response pair of some of your proprietary or PPI data, all that, just the standard rules. Don't put your company's data. Don't put PPI data through those open windows. But if you're behind an API, if you're a paid version, there's protections, and they're not putting it in there. Number one, they're probably also sorting preference of what they want baked into the training models, and half the garbage people are putting in, they're like, we're going to keep that away from the training model. But get your hands dirty, play with it. That's the only way that we're all going to shape this together. So that's the end of the talk. But questions, what do you guys got? Anything? We're tired. That was a long hour and a half. Yeah. I can say that I'm actually interviewing right now, and super impressed with the 4 candidates. They're all masters, 1 undergrad from Georgia Tech, and the problems that they're engaging. Making a RAG model so they can actually talk to their car, meaning you can load in the maintenance model, you can load in all the information from the internet, and you can actually talk to the sensors, and you can actually have a language conversation with your car. Yeah. What? Well, you can find out exactly what it takes. The car can tell you, it's got error codes, and it can tell you, you can ask for. So I'm going back and learning Python. The last 2 years, programming language Python. I'm a dinosaur. I learned MATLAB in graduate school. I was hardware based the first half of my career. Second half, I'm now coming back, loving the data science, which was baked into what I did. But I'm having to learn Python, a new language. 24 months ago when I started learning it, a lot of time going and searching for what library am I looking at, what's the function call, what are the variables I got to load in, what's an example, and then you come back and you try it and you work. Now, everybody, they got copilots that help you code, that I can literally go load my data frame, get it loaded in there, and I can say, I'm trying to compare these 3 columns and I want to group by this, and the Python language comes out like that, and I just hit execute, and it does it for me. So I can now engage with my data just with natural language. I think that's fascinating. It's accelerating me up the learning curve very, very fast. So any other comments, questions, or tools that you've heard of that are crazy, that are awesome, that you're afraid of? Anything?
Better prompts as well.
Yep. More and more, they're helping shape your prompts to say, include this and this. Did you have
I have an intern with a senior at school, and she gave me a piece of work, and I was like, wow, this is really flowery language. And she's like, yeah, I asked GPT to make it more formal. And then I was able to, these 2 paragraphs literally say nothing.
Right.
And it just strikes me, but so what I am worried about, or I'm curious about, is how the education and training, like if this senior in college doesn't know that that's poor writing, that says nothing, like that's the scary thing for me. Like, how do we create better education systems to handle this new paradigm?
Yeah. Well said. It's a big concern.
And for us communication professionals in the world that watch all this do, now granted that sometimes it comes out and it makes no sense and it's not relevant to, just with fancy words that meant nothing, but it's a pretty scary prospect. I saw an ad on LinkedIn yesterday that says earn up to $25 an hour teaching AI to write better. I was like, it was titled Skilled Writers.
Yeah. Well, I mean, here's from my concern. When words are kind of used to value you within your organization and your career, think about a mid-level manager that writes a weekly report or writes the ones that were highly valued in companies were the ones that could communicate well and give situational awareness. If now that can be done in a drop of a hat, I mean, what do we need? Is that many middle managers? I mean, anybody that values their career on words, I don't know. What does this mean? I mean, you're not going to go away. But it could be that you could scale up pretty quickly. You might not need to hire as many of something that's going on in that career field. I don't know. This is just an interesting, so. All right, I believe we're all very tired. Thank you all for participating. That was good.
Thank you.